Let's take a look at a dosage calculation. I want to do A here. What these types of problems want you to determine is how much of a particular radioactive sample needs to be administered to a patient based on that patient's weight. And these are the two main pieces of data that you always see, the mass of the person as well as the recommended dose per body mass. Okay? And so basically we're going to go from mass to dose, or in this case kilograms, and let's see, it's wanting it in millicurie, so we'll go ahead and ink that in millicurie. And so they're using the unit of activity, right? How much radioactive sample is there to determine the dose of the medicine. Now, just a little reminder about dimensional analysis. What you're looking for is a set of conversion factors that allow you to do this particular transition, kilograms to dose. Now, we have a relationship here. I'm gonna write this out a little bit different way. What it's saying is that for every 1 kilogram body mass, you need to administer a small dose of radiation, basically 20 microcurie. Well, right embedded within that relationship is our connection between the two types of units, right? A unit dealing with mass to a unit dealing with dose. Now, notice that the specific unit for dose is in microcurie here, and it's in millicurie there. Well, as it turns out, you're given a conversion factor for the second step in the calculation. So let's take care of this. Okay, so you start with the data that's given, this 50 kilogram value. And notice this one has 3 significant figures to it. Right? If the zeros on the right-hand side and the decimal shown, then they are significant. And what you're doing in dimensional analysis is basically setting up this little, what I call mathematical template. Keep track of how you're going to multiply and how you're going to divide by in the course of the problem so that you go from units of mass to units of dose. Right, we're going to use this first. Right? We're starting with kilogram. We want to look for that other unit of kilogram in our expression, in our information, which is there. Dimensional analysis logic, if you will. The unit that you start with, that's what you want to get rid of. That's what you want to cancel out. So I'm going to put kilograms on the bottom. All right, kilograms divided by kilograms, it's going to disappear. And then the other portion of the expression will go on top. So again, mathematically, anything divided by itself goes to 1. So mathematically, kilograms get canceled out here. And now we've transitioned to this unit of dose. Now, we don't want to stop there because, again, we want to go now to millicurie, and that's where this conversion factor is going to come into play. Just like before, right? What unit are we starting with? What do we want to get rid of? Well, it's that one. Whatever unit you want to keep is going to go on top. And again, mathematically, what you're looking at is that those cancel out. And now we're left with the unit of interest, which is our 1 millicurie. I describe this as a mathematical template. Well, what I mean by that is that in the course of setting this up, what it tells us is that I'm going to multiply by 20 and I'm going to divide by 1,000. Basically, anything on top, you multiply by. Anything on the bottom, you divide by. Now, the reason why I didn't mention these two in my little spiel there is because you're dividing by 1, multiplying by 1. Mathematically, it doesn't affect anything. If you run through this math, well, you get 1. Now, we don't just get 1 here. We also have to sort of factor in our significant figures. And what I want to point out, again, this one has, let me write it down here. This one has 3 sig figs. And then the other bit of information is in our dosage here. The 20, notice they're adding a decimal there. That's 2 significant figures there. The rule for multiplication and division is that whichever data point has the fewest number of sig figs, that is going to dictate how you round off your final answer. So this one is 1.0, and then you always want to include your unit, millicurie. And then just as a follow-up, any type of conversion factor you use, especially the metric ones, you can ignore the sig figs there. The reasoning behind that is that this relationship of 1 millicurie is equal to exactly 1,000 microcurie, that is an exact relationship. Exact relationships, there's no uncertainty in that value. It doesn't affect your significant figures any. Right? So it's just the data that's given to you that dictates how you round off with respect to sig figs. Okay, thanks.